Okay, and then we use the ratio of 2 moles of aluminum ions are in 1 mole of aluminum carbonate. And then from here, we just need to use the molar mass of aluminum carbonate. That's a 3 right there.
That's running to me with the same, right?
Well, that's bad. And the molar mass is something that they didn't give to us, so we had to figure that out ourselves. All right. For number 2, I'll let y'all work on that for about 2 minutes. We'll see how far y'all get. And then if you already did it in class.
2 minutes. Counting down.
That's very good. Okay. If you already did it in class, it wouldn't hurt to do it again. You can try it. Just more practice. Oh, that's all right. What? What's so funny? Oh, okay. Let me zoom in. I'm sorry. Is that better?
Yeah.
Okay, cool.
Oh, she don't know.
Go ahead, move on. It's okay. Next time though, it's minus 10 points on your exam tomorrow. I'm just kidding. I'm just kidding.
No, it's like -5 for each word you speak. While I'm muted.
Okay, I'll let you do the next one.
I mean, we're kidding, by the way, but still.
Yeah, we're just. Series says there is how much time left? 22 seconds.
30 seconds.
We gotta do the last part. Actually,
And time. And by the way, you can find this on the group me as well. I sent the link earlier. So a glass bead has a density of 2.85 grams per milliliter. 20 glass beads having a mass of 15.85 grams are added to a graduated cylinder with an initial water level of 12.1 milliliters. What is the final volume of the graduated cylinder after the beads are added? So first of all, is density considered an intensive property or an extensive property?
Intensive,
Why?
because it doesn't change with the size if like the size gets bigger or the mass gets bigger.
Yeah, it's independent, we'd say, of how much is added. So density equals intensive. But what does that mean for this problem? That means that, what's it called? The density of one glass bead or like 50 million glass beads will be the exact same because it doesn't matter on how much is added. So the density of one equals density of infinite amount. It doesn't change basically. So what some people will try and do, a common mistake, is what's the formula for density again? Yeah, so density equals m over v. What some people will do is for the m part, they'll take the 15.85 and then divide it by 20. Why is this wrong? Exactly. So you can't say what's the mass of one glass bead and then do it from there. Like it'll be the exact same. So right, what we do for our mass is we straight up put in this 15.85. And then we need our volume. So it says an initial water level of 12.1. So what I'm going to do here is actually change this V to a delta V. What that means, right, is it's a change in the volume. So Well, that means it's the final volume minus the initial volume. So in this case, right, we want to know the final volume. So we're solving for V final. So what we're going to do is we're going to do V final, which is what we're solving for, minus the initial. So initial water level of 12.1 milliliters. And then we could say that the density of one is the density of everything, right? So it'll be 2.85 grams per milliliter. That would not change. Now, from this point forward, it's just simple algebra. It's just plugging in your values and then playing with it. So 15.85 equals 2.85 times VF minus 12.1. So if we pull out our fancy calculator, which is situated somewhere here, we will get that if we simplify the right side of the equation, right, we get 15.85 equals 2.85 VF minus 2.85 times 12.1, 34.485. How I got this right was I distributed the 2.85 to both terms. So 2.85 here, that there. And then what we got to do from this point forward is solve for our VF. So we're going to add both sides by 34.485. 34.485 plus 15.85. We'll get a value of 50.335 equals 2.85 VF. Now, what's our final step to get the final volume? Yeah, divide both sides by 2.85. And then we'll get our VF to be round answer to three significant figures. So I got 17.66140,351. But in three sig figs, that would be equal to 17.7. Sorry, I should make that clearer. 17.7 milliliters. All right. Yeah. So F stands for the final, and then I stands for initial.
Can you show the whole problem so I can take a picture, please?
There you go. And if that seemed a little complicated, there's another way you could have done it. I think it's simple, a little bit more simpler. So we know the density is equal to the mass over the volume. We're going to look for the volume of just the beads. So we're going to isolate that. So volume of the beads is going to be mass divided by density, which we know is what is it? It was 15.85. And the density was 2.85. Yep. So grams, 2.85 grams per milliliter. This is going to give you a volume. 5.56. So this is not the volume of the final volume. This is not the answer. This is the volume of the glass beads. So 5614 mLs. If that's the volume of the glass beads that we're adding to the volume of water or whatever solvent or liquid it was, yeah, water, you just add the two volumes and you'll get your final volume. So it'll be 12.1 milliliters, which will give you the exact same thing of 17.66, which is 17.7. I think I personally would have done it this way on the exam. It's a lot less movement of variables and multiplying and dividing and knowing when to subtract and all these things you have to think about. But the key thing for this part is for Rich's part, you got the answer. The answer you got was the answer for the question. But for this, the answer you get after finding the volume of the beads is not the answer. You have to just add the initial volume of the water to get the total volume, right? So that's how I would have done it personally, whichever way you like better. I know some people like math, so they like to do math, but I think to save time on your test tomorrow, try to do it the quickest way. And I think this might have been the quickest way. All right. Any questions on 2? So what I'll do is I'll move this one over. And then so you can see both ways that we solved it, and you can choose which way you like the best. And do that tomorrow. Number 3 is saying which of the following compounds is not an ionic compound. Give you 30 seconds. This one actually was one of the ones, everything that was similar to this problem, y'all did well on. It's all the math problems that we didn't do good on. So I'll let y'all decide, work on that for a second. Maybe 20 more seconds. And time. Okay. That was okay. So what are we thinking? We know it's asking for what is not an ionic compound. So it's also this is the same thing as saying which of these is covalent. All right. We can first eliminate the things that have metals, right? Because we know that's going to be ionic. So which ones have metals? Out of that. Correct. Yeah. So which ones have metals? A and D. Perfect. Aluminum is a metal. We use that when we're cooking all the time. And calcium is a group 2 metal. You might not think calcium is a metal, just because we find that in our body and stuff, but it is a metal. All right. What about between B and C, or is the answer 2 of these?
For Gentian 1 is ionic, maybe just opposite bonds, like opposite charges, or we stick with metal.
So I see what you're saying, because one of these has all non-metal atoms, but because when you break it into its pieces, this one is made out of the ammonium ion, also known as ammonium cation, therefore comes together with a chloride anion, making this ionic compound. Even though it's composed of both, even though it's composed of only non-metal atoms, it's still an ionic compound because of the fact that it uses the charges to bond. It's not using covalent bond, it's using electrostatic interactions to bond. So that's a Cl minus. So with that, C is the only one that is covalent. Nitrogen monoxide is how you would name it. All right. Are we good on that? Or what's another, maybe you might see something like this on the test tomorrow, maybe. Ammonium carbonate. This is only containing non-metal atoms, but it's another example of an ionic compound that is composed of only elements that are non-metals. You have the ammonium cation and the carbonate polyatomic anion. All right, that's just another example. Any questions before Rich takes over for the next one?
Oh, all right. So question 4, this is probably going to be, this is the hardest topic for a lot of people that we've taught in the past. So I'll maybe give y'all, say, 3.5 minutes.
Yeah. What's the time per question on the test? It's like 3 minutes and some seconds.
Well, let's calculate it out again. We have 90 minutes and then it's 25 questions. So 90 divided by 25, we should be taking 3 3/5 of a minute. So you should be taking 3 minutes and 36 seconds per question.
Hey, how many questions did you say?
There is gonna be about 25 approximately.
Oh, okay.
Yeah.
Either stretch marks or. I think it's. And maybe from chili. Fellow. Teacher walked up to me.
All right. Just for that.
Walk through the whole room. and give him a look.
Might just take a hefty swig of my drink along with it.
Wow.
This is over to it, just. The time of the.
About a minute. 1 minute. You a minute.
Here's one of the instructions.
Yeah.
Walk down and then you'll pass a vending machine. Keep going straight until you see us.
You have to take a left, right?
Yeah.
Yeah. Oh, don't want that. Also, no vapes are allowed in the testing room. I just want to make that clear because last semester we found someone vaping mid-test.
Oh, yeah. Yeah, I remember that now.
So just
Yep.
wanna, like, I know,
I'll be like Andrew Tate, the vacant room. Top G.
I don't know. Time's up.
So random, I'm sorry.
Anyway, given the following equation, manganese solid plus O2 gas makes that thing. Nobody cares about the name right now. What is the percent yield of the reaction if 88 grams of magnesium, or not magnesium, manganese reacts with 62 grams of O2 to produce 115 grams of that manganese 5 oxide, in case you were wondering. So, what's the first step in this problem? Yeah, he was nice to you when he said it was unbalanced. Straight up told you. You're not always gonna be that lucky. So manganese, y'all like the orange, by the way? Yeah, okay. Plus O2 gas makes Mn2O5. All right, what were y'all's coefficients when you balanced it? 4, 5, 2. That is correct, is what I got as well. So, what is our next step? So this is step 1. What is step 2 of this problem? Yeah, so you line up all of your stuff and then find the limiting reactant, basically. So 88 grams of manganese and then 62.0 grams of oxygen. What's the molar mass for manganese? It's 55.845 grams per every 1 mole.
843.
Okay, one thing off.
I'm just kidding. It might be 845.
What is it though, actually?
You can use my periodic table.
54.9.
54.9? Manganese. What is manganese?
Wow, it's right there.
54.938. Crazy. Oh, 55.845 is probably iron or something. What was the number? 54 point something?
0.938.
0.938 grams in 1 mole. All right, and then do the same thing here. So now we're going to use our mole ratio. So to get the moles of the product. So for every 4 moles of manganese, there's 2 moles of Mn2O5. And then we'll do the exact same thing for the oxygen. So there's 32 grams approximately in 1 mole. And then for every 5 moles of oxygen, there's 2 moles of Mn2O5. All right, so solving this out with our fancy calculator device, we'll get 88 divided by 54.938 times 0.5, because 2 divided by 4 is the same thing as a half. So we get 0.8009 moles. And then we'll do 62 divided by 32, then times 2 divided by 5. And we'll get 0.775 moles. With that being said, which one of these is our limiting reagent? Which element would that be in this case? It is indeed oxygen gas. So oxygen is gonna, this is our limiting reagent. All right, so what we're gonna do, we're gonna get rid of this manganese stuff because we don't need it. And then move this up a bit. All right, so we get 0.775 moles of Mn2O5, right? When we make, what's it called? With our limiting reagent. What's our next step? The theoretical yield?
Yeah.
Yeah, so you solve for a theoretical yield. That's definitely what she said. So solving for that, we get, dang, now I wish I didn't erase it. Was it 54.930? 8. So we're going to calculate our molar mass of manganese 5 oxide. So 1 mole and then times 2. And then this is 5 oxygens. So that's 32, 64 plus 16, that's 80. So plus 80. And it's 189.876 about grams. And then we'll multiply this by 0.775 to get our theoretical yield of 147.15. Probably made this a different step, but yeah. Step 2, step 3, yeah. Yeah, so what I did, right, was I found the moles of my product from the previous step. Then from here, I calculated the molar mass of this. That's where this number comes from, by the way. Yeah,
I have a question.
yeah.
So can you just explain real quick the relation? I know how you got like the mole of oxygen and then how you like I guess it turned into the mole of Mn2O5, right?
Yeah.
What's that relationship? I guess like the background.
So basically, when you react these together, like however much like quantity you use, there'll be like the manganese and the Mn2O5 will always exist in like a 2-to-4 ratio. What that means, right, is that however much magnesium you react it with, you're going to get like approximately half manganese 5 oxide.
And that comes from the balanced chemical equation that we balanced. That was given to us, but it was unbalanced, so we had to balance it. So those coefficients that you see but in the equation, in front of two, in front of the O2, the 5, and then the Mn2O5, the 2, that coefficient, those are the ratios that he's talking about, and that's what we use to convert from 1 mole or from a mole of reactant to a mole of product, or from a mole of reactant to a mole of another reactant. It's the ratios that we always use in these types of problems.
So 189, that's the molar mass.
Yeah, that's a molar mass. So you get 147.15 grams. So right now it's time for our final step, solve for our percent yield. What is our formula again for percent yield?
Actual.
So our actual A over T times 100. The A is always on top of the T. It's one way to remember. A 115 divided by 147.15. 115 divided by 147.15. Solve that out. You will get 0.7815. Oh, and the A over T thing's kind of dirty. Wait, my parents watch these videos. Never mind. Times 100. Solve that out. You will get write your answer to 3 significant figures. So this will be 78.2%. That is our final answer. All right. To sort of recap what I did, I balanced out the chemical equation. This was my first step. Then I found my limiting reactant by converting the grams of what I had into the moles of the product, and then seeing which of my moles of product calculated was less or the least amount, because the limiting reactant limits how much product I can make. Then I converted my moles of product into grams of my product by multiplying by the molar mass, which would give me my theoretical yield. Then I use the formula for percent yield, our actual over theoretical, and then I solve for our final answer, the percent yield. All right. That being said, any questions?
Really makes sense? Awesome. Please ask your questions. You're gonna see very similar questions on tomorrow's exam, so if you have any pressing questions that you might be too nervous to ask now. Or like Rich always says.
Speak now or forever hold your peace.
Yeah. Okay.
You said it. You said it.
Okay, number 5. I'm thinking this should take maybe 2 minutes. Maybe a minute if you are good at dimensional analysis. I'll give you.
30 seconds if you do it one. So yeah, 2 minutes is a good time.
All right. Hey Siri, start a timer for 2 minutes and 1 second.
2 minutes, counting down.
How much longer did Yoshimoto go over that? 30 minutes. Yeah. Dude, 30 seconds, switch into my 5. She can open the spot. Yes. Yeah. I don't know if I would though. Can't do all of this. All right. I said all right, but it's not time. Yeah. Sorry. Continue. 35 seconds.
Is it possible to share whatever's on that on the Zoom? That'd be cool.
Really? Using old stuff is cool. I'm kidding.
Old is gold, but it's a.
Old is the. Yeah. 3, 1. And time. All right, how many of y'all got to finish? Okay. What did you like, when did you stop? Okay, so let's go ahead and. If I didn't know where to start, I would have always started with what we're given. So 45.5 kilometers per second. Oh, why did I write 6 second? And they give us this unit conversion of 1.6 kilometers for 1 mile. Okay, so
For useful information.
yeah.
If they give something to you with a problem, you probably should use it.
Mhm.
Yeah.
So maybe you got to this point, and maybe after this, did you get to this point, or
Extra information.
and then what was your? Okay, yeah, so there's a few or not, I guess conversions, numbers that we need to remember. And one of them is that there's 5,280 feet in 1 mile. And that'll help us out. So I don't know if y'all have ever heard it like this, but the way I remember, or at least remembered for a long time, was someone said 5280. I don't know, 5 tomatoes or something. 5280. I don't know. Okay, maybe that's wrong. Maybe that was a waste of time. But maybe 5 tomatoes is gonna help you remember this now. 5280.
Or
Okay.
better yet, what's the nickname for Denver? The
Mile High City.
So it takes 5,280 feet to get to Denver. 5,280.
Yeah, honestly, whichever one helps. 5 tomatoes. Yeah, just think of 5 tomatoes, okay? 5280. Now we have 5,280 feet, also known as 5 tomatoes feet in 1 mile. And does that check out for one of our units, one of our desired units? Right? It says it wants it in feet per hour. So that's feet right here. We just canceled out all these units. So kilometers cancels out. Miles, oops, sorry. Miles cancels out, and we're left with our desired unit, which I'll circle in a different color. All right, that's over here. Next thing is to get to the hours. Right now we're in seconds. So now let's start thinking of things we know, everyday things, right? We know that there's 60 seconds in 1 minute. Or you could have also said that there's 3,600 seconds in 1 hour and go straight to hours. But I don't really, I guess, remember that. I think there's 60 seconds in 1 minute, and we know that there's 60 minutes in 1 hour. So let's check to make sure this works out in our favor. So the seconds cancel, minutes cancels, and we're left with hours, which is right here. So our units are perfect. All we have to do now is put this into a calculator. So 45.5 divided by 1.6 times 5280 times 60 times 60. I must have done something wrong. That's a big number. Oh, well, that makes sense because we're going from kilometers to feet. All right. 54000. Yeah, okay. Yep, so that's the number. I don't know who would want these units. This is why we use kilometers per hour and not kilometers per second, or anyways. How many decimal points is that? 5.41 times 10 to the 8 feet per hour. Imagine a cop pulls you over and is like, Sorry, you were going 5.41 times 10 to the 8th feet per hour. You were over the speed limit. It's like,
I caught the real stem maker.
okay, so that's why it's probably not a desired unit. You'll only see it on your Gen Chem 1 test to make sure that you can do those dimensional analysis problems.
All right, this next one will be a double whammy. Why did I say that? Okay, anyway, I'm gonna give you all.
Hey, I have a quick question on that last one.
Yeah,
How did you, I messed up because I didn't put the seconds like under it like that, like a
Okay.
denominator.
yeah, so it's important that when you 45.5 kilometers per second, that means it's in the denominator. So some people, you may see it written like kilometers per second. It's literally the same thing. I just extended this line a little bit further, but that's why it's on the bottom, because it's that per that causes it to give us the unit of velocity now.
Okay,
All right.
thanks.
And from there, you have to make sure that seconds is on the top to cancel out everything else. Perfect. Answer your question?
Yes, thank you.
Perfect.
All right, anyway, here's my double whammy. I'm gonna give you all 2 minutes to solve both problem 6 and 7. I hate nomenclature, by the way. Whoever designed a freaking IUPAC system.
They don't know what that is yet. Sorry.
Anyway, no nomenclature sucks. One point I'm trying to make.
Okay. Rich, go give me that chemical off the shelf. Which one? The one bottle right there. That's why there's no picture, silly.
Yeah, compound A. I'm not gonna call it 2-methyl, 3-ethyl, 4,5-dimethyl.
And what happens when you reach compound Z, the last letter in the alphabet?
Go double A, that's what Excel is.
Thinks everything should be ran like Excel. That's a clickbait type. TAs discuss, TAs debate over nomenclature. I don't know. You'll word it better.
I like TA says double whammy.
Yeah, for sure. You start a timer, Rich?
It's been 30 seconds.
You've been counting?
Set a timer for 1 minute and 30 seconds.
These conceptual questions, how to go about it. I guess that I consider them conceptual because it's testing more about chemistry, I guess, than math. I mean, the limits and reagent ones are chemistry too, but how do we feel about these type of questions? Oh, yeah, there's a lot of memorizing that has to be done, unfortunately, for these. But once you are able to do that, I think you can, like, the amount of time you spend on the math questions on the test, probably will take longer than these. So if you can get these done faster, you have more time to spend on those math questions. We probably won't finish it, yeah. All right.
30 seconds.
I think they're probably done by now. We can just. And
Tie. All right, let's whammy the double whammy or something like that. Okay. What is the name of Fe parentheses HSO3 close parentheses 3 question mark? What'd y'all get? D, iron 3 bisulfite. Let's go through it. So right off the bat, I notice iron, right? Is iron one of those, or what is iron? Is it a metal, a non-metal? None of the above?
shout it out.
It is, yeah, it is a metal.
That's what the whole, that's what the whole iron age was about, right? Starting using iron to build that, not really like.
Anyway, while he fixes that. So iron, right, is a metal. So what do all metals do? Or what is what am I trying to say? What is iron one of your exceptions, like a metal that only has one charge? Right, so what needs to be on there whenever you name something with iron? Yeah, Roman numeral. So right off the bat, I can cross out A, E, and F, because I don't see any Roman numerals there. So here's how your test will be, right? All of your answer choices will be common mistakes people make when writing out the name. Like, for example, we already crossed off 3 of them because we know it has to have a Roman numeral. All right, now let's pay attention to this part. HSO3. What does that correspond to? So SO4, right? Let's go through this. SO4 2- is what? Sulfate. So sulfate. Now let's take off an oxygen. SO3 2-. What's that? Sulfite. And now what happens when you add an H to something?
Is the bi, is that from the height?
Yeah, that's the bi. Another way of saying this, right, is hydrogen sulfite. So this is either hydrogen sulfite or bi sulfite. So right off the bat, we know there has to be a bi in here. So we can cross out option B. So correct answer is D, iron 3 bisulfite. All right, so questions on any of that, how I got to that answer? All right, what did y'all get for number 7? B, H2CrO4. I, in fact, agree with this answer. Let's go over why. So, chromic acid, what does that come from? Yeah, because the IC, right? If you have an IC, that means it's an ATE ion. So this, like the IC comes from the fact that there's a 8 in the polyatomic ion name. So right, this one specifically is chromate, CrO4 2-. So that is chromate. So the formula for chromic acid, since it needs to be neutral, you need 2 hydrogens or 2 positive charges to balance it out. So H2CrO4 is the answer. What's wrong with this one? How'd you name this one? Yeah, so it would be dichromic acid. So this is a matter, right, of just memorizing your polyatomic ions. What about this one? Can you speak a little louder? Yeah, so what would you call the acid? Chromous acid. So IC corresponds with the ATE ending, and then OUS is the ite ending. What about this one? So hypochromous acid. All right, what about this one? I don't even think this exists, but what would that theoretically be? All right, let's try this. What's the name of this acid? Hydrobromic acid. So similarly, this would be hydrochromic acid. Yeah. So any questions on that? Y'all get it? Nomenclature sucks, yeah. Okay. All right, and with that, it is 4 o'clock in the PM. So yeah, we will pick up with this worksheet tomorrow, 2:30 PM. SCB 3.146, pull up, be there, be triangle, as they always say.
Can I pull up on Zoom?
You can indeed pull up on Zoom.
Pull up skirt.
All right, thank you all for coming. Have a great rest of your day.
Wait, what did you get for question 6 again? I didn't see it.
Wait, what was that, sorry?
What did you guys get for question 6? I didn't see it. If you
Six,
can-
the answer was D.
Okay, thank you.
Yeah.
Do you have any tips for remembering?
Oh, yeah, so you literally just.
Make flashcards. I honestly,
The actual rule. And you have to find a theoretical rule. And it's literally the percent yield equation, but.
yeah, I'll try to get it posted as soon as possible. What's the last one? What's the last video on there? Cause I'm not gonna post this Monday as well. What's the last video on the YouTube channel? The last I posted Monday.
Hi, I'm sorry, but during the next session, do you guys think we're gonna go over like number 12 or number 17?
Yeah,
Yeah.
we'll definitely get to those tomorrow, for sure.
Okay,
Alright,
See you, man. Keep studying. Make sure y'all try to practice these before, like, do them before, and then you can come here and we'll go over them. Deal.
yeah, I won't.
Skybridge, forgetting prizes left and right. Wait, there's a lot of people. Anyone have any questions before? You can stop the recording.